Right. Let's begin. So would like to remind you again about this one Neumann architecture, which is thought program concept before we begin. And actually we have already discussed that, but the thing is like, you need to remember this. Actually, I think I have given this animation to you. That is recall that fetch cycle, stretch animation. So when you search and you'll get this, there are a lot of animations, and out of that you can select one. So I prefer this one. I prefer this one. I hope I have sent you the links about this. And so because there are some questions which cover this section. So here, actually, this is related to the next part also. That is why I'm reminding again this volatile and non-volatile memories, SRAM. Actually, this is you call registers and cache memory as SRAM. This is the main memory. This is dynamic RAM. And in the dynamic RAM, this is assembly programming code. Right? It has assembly programming code. So this is the second generation language. We discussed about the first generation language. In first generation, it is machine language, only binary. But when it comes to the second generation, it is updated. It has updated to the second level, which is assembly language. Assembly actually has short codes representing that binary, same binary, but the thing is it uses short codes. Otherwise, you have to write everything in binary, raw binary format, which is lengthy. But this is some short version, but still it need to be translated using assembler. Assembler is translating that actually when this instruction is fetched into the processor, inside processor, there is something called control unit. Control unit can do the translation and understand the instruction, right? So we will further discuss this. About this, we will discuss more deeply. But for the moment, just remember that there are registers inside the CPU. Actually, there are two kinds of registers. So register type 1 is we call, that is a GPR, general purpose register. So if you don't know, please write down general purpose register. So that is that's doing basic tasks of storing data and instruction. Then you have SPR. SPR means special purpose register. So these special purpose registers, there are. So did I give you the duties of each of these registers or not? What CIR does, what MAR does, what MBR does. I think I have given that, right?
Yes, sir.
Right, okay. So those are special purpose registers. Right, now you have some idea about what's happening here in this level. So basically about the special purpose registers and their tasks, and the general purpose registers, which is inside the processor. So actually buses are the transport mechanism. Buses transport data from registers to memory and memory to registers. Memory to registers, registers to memory, and also internally inside the system unit, it transport data. So that is buses. Right. Now in today's discussion, we have to move to the next, which is memory hierarchy. Right. So in this lesson, we have just learned the stuff related to different kind of memories, and these memories can be organized into a hierarchy, so which forms a kind of pyramid. So when you search memory hierarchy, you will get a pyramid. And there's a diagram, and this diagram is a pyramid, and in this higher level of this diagram, so it is faster memories are stored in the higher level. So let's see this. So this is a clear diagram about this memory hierarchy. I would like if you can draw this, since So sometimes you will not be able to discover this inside when you are searching. That's why I ask you to write this, draw this, and I'll explain, right? So this is just the summary. I'll explain the summary first. After that, I'll give you time to do. Okay, so what is it? Initially, there is a processor. Inside processor, you have registers. So registers are super fast, super expensive, and it has very tiny capacity. This is fast and expensive. It stores in bit levels, right? Tiny capacity, small capacity, bits only. It can store few bits or byte, few bytes, few bits. So, but when it comes to the cache memories, there are 3 cache levels: level 1, level 2, level 3. Out of that, level 1, level 2 are inside the processor, and level 3 is outside the processor, but still attached to the processor or linked to the processor. That is level 3. So level 1, level 2, level 3. Likewise, there are 3 categories of, or 3 levels of cache. Cache is basically the memory inside the processor. Altogether, we call these memories another name that I would like to write here. All these memories are type of SRAM, or static random access memories. SRAM, or static random access memories. All of these memories, registers, cache, we call them SRAM, static random access memories. And here you have the physical memory, that is DRAM. Right? That is called DRAM. So this SDRAM, DDR SDRAM, both of these we call DRAM, dynamic random access memory. In addition to the pyramid which is given here, you can write down this. This part is called SRAM, static random access memory, and this part is called dynamic random access memory. Then the next fast is SSDs, solid state devices, and then you have the mechanical hard drive, file-based memories. So those are cheap and having higher capacity, less expensive too. It's cheap or less expensive, high capacity, and those are slower than the memories here. And there is another level which is not indicated here. I would like to draw that as well. So that is why I asked you to draw this. There is an update, and this is called network storage. It is even slower and really cheap. Sometimes it's free as well, and it is it has very large capacity. So this is called, these are called secondary storage. And whatever you can see, this SRAM, DRAM together, we call them primary. That's why I said you need to update. These are called primary storage. These are primary storage devices, SRAM, DRAM together. Then solid state SSD, mechanical hard drive, CD, DVD, CD, DVD, those are also under the secondary storage, right? Blu-ray. So those are also under the secondary storage, which is slower than the primary storage. And the next thing is you have third level, you can call them the network storage, tertiary storage, tertiary storage. Okay, now the diagram is complete. Now you can draw it in your book. Right, the next. Now we have clear idea about the memory hierarchy and how it formed, and what are the memory types, primary, secondary, and how the speed, how fast these memories are, what are the dynamic, what are static. So static means it is fixed, it has allocated resources fixedly, so you don't want to reallocate them. But these DRAMs or dynamic RAMs are periodically refreshing and rearranging things again and again as it is dynamically allocated, not statistically, not static, sorry, it's not static. Okay, then, so we just learn about them, and then the volatile memory and their characteristics. So these volatile memories are the dynamic RAM, SRAM, DRAM, SRAM, all are volatile memory, right? So what are these categories of memories? So basically RAM, random access memory, or SRAM means, so you don't need to know those terms, static, random access memory. Random access memory means any location of the memory can be accessed almost equal within almost equal amount of time. So DRAM or dynamic random access memory is the next category, that is dynamic, not static. You need periodically refreshing, dynamically allocated. I said example about this. If there is a one cap, so then if you are exchanging this cap so faster, so then whoever observing can see there are two caps. Two people are wearing caps because of the fastness of refreshing. But actually, if you have given two caps, so both will have caps physically, but that is much expensive, and so that is costly, expensive, and it will take more space. But dynamic RAM, it will not take that much of space for the storage, but it is statistically, sorry, that is dynamically allocated. So which is slower than the static RAM, need periodical refreshing. And there are type of DRAMs, type of dynamic RAMs. So one is SIM. So SIM means single inline memory module. Single inline memory module. So you can just remember this. So this SIM is similar to mobile phone SIM. That means the connecting surface is only in one side. Only one side, the connecting surface only in one side. So we call single inline memory module. SIP කියලා තව category එකක් තිබ්බා. I'm not going to remind that, but SIM is important because SIM was all DRAM. All DRAM was a SIM, single inline memory module. SIM, single inline memory module. This is what the SIM is, and if you see a picture, you can understand. In this, only you can see the connector surface only in one side. එක පැත්තක විතරයි මේ connector එකව තියෙන්නේ. මේකේ අනිත් පැත්ත ගත්තම මේක කරකවල ගත්තොත්, if you rotate this the other side, you will not see any connection links. That is SIM. So connection surface is only one side. But when it comes DIMM or dual inline memory module, so that has connecting surfaces both sides. ඒකේ connector එකව තියෙනවා දෙපැත්තෙම. So just get an idea. Single inline memory module or SIM will have only one side. So that is similar to the SIM card that you see. It has that connecting surface, or this, you know, this pins only in one side. එක පැත්තක විතරයි pins තියෙන්නේ. Right? But when it become DIMM, dual inline, oh, just think about a memory card. Memory card, it has only one side. Connecting surface is only one side. But when it become DIMM, both sides have pins. So higher the number of pins, it will be faster. Transaction will be faster since it has higher number of pins. Pins වැඩි වෙද්දී transaction faster. දෙපැත්තම pins තියෙනවා. ඒතර මේ පැත්තෙත් තියෙනවා. If you rotate the other side also has pins. So then it will be faster when transmitting data and information. That is DIMM, or the second category, dual inline memory module. That is the second category of RAM, DRAM available. Then there is another category that is called RIM, RAM bus dynamic or RAM bus inline memory module. RIM, RAM bus inline memory module, that also has both sides, but it has direct connection or direct link to the processor. That is the specialty. RAM bus has a direct link to the processor. Processor and RAM are directly connected using a bus. Bus means a data path. So you have direct data path to, in RAM bus inline memory module, there is a direct data path to processor from RAM. That is RIM or RAM bus inline memory module. Okay, examples for SIM. There is something called fast page mode RAM. And there is another one, hyper page mode RAM. Fast page mode. And these are a bit older. Fast page mode RAM, hyper page mode. I'm not going to write the meanings, but so try to remember. So if you want, you can just listen to the recording again. Fast page mode, hyper page mode. These were some old RAMs. In DIM, you have two categories, that is synchronous dynamic random access memory, SDRAM, and there is another one, double data rate, synchronous dynamic random access memory. So normal SDRAM, normal synchronous dynamic RAM, right? It will communicate data half speed of double data rate RAM. In double data rate RAM, so it has dual inline. Dual inline means in both sides it has pins, and also the data rate is double when compared to its predecessor, which is SDRAM. Actually, some people in the commercial terms, they call SDRAM, DDR-RAM. SD and DDR, but both are SD, right? Both are synchronous dynamic here. This one also synchronous dynamic. But the thing is, the first one is synchronous dynamic and the second one is double data rate. It has double 2 times of data rate than the previous RAM. So that is the specialty. An example for this RAM bus dynamic RAM bus inline memory module is RD, RAM bus dynamic random access memory. RAM bus dynamic random access memory. Basically, these RAMs are used in servers. Now it's not much popular because these DDR RAMs are much popular than this RAM bus RAMs. It is cheaper, relatively cheaper and faster. Okay, so please write down the SDRAM, SRAM, DRAM. DRAM's 3 categories: SIM, DIM, RIM. SIM examples FPM, HPM. DIM examples SDRAM, DDR-RAM, and RAM bus inline memory. RIM example RAM bus dynamic random access memory. So RAM bus has a special data path from RAM to processor. So that is the specialty. Then it is faster. Normally other RAMs transfer data into motherboard. අනිත් RAM කරන්නේ මෙහෙම අර පින්තූරේ තිබ්බා වගේ කලින් according to the picture that you saw in the this one. So first what will happen, it will transfer data into the motherboard and then the motherboard will transfer data into the memory. Processor to motherboard, motherboard to memory. But in this style of RAM, in the RAM bus RAM, processor to memory, memory to processor. So it's like a secret, not secret. It's like a direct path from RAM to processor and processor to RAM. No need to send to the motherboard. But other RAMs send processor to motherboard and motherboard to the RAM memory. Memory to motherboard and motherboard to the processor. It is using the common bus, but here this is using a private bus. This is a public bus. So everyone use this bus, but this is a private bus, personal bus from RAM to. Okay, and I hope that you know the commercial definitions after this. DDR RAMs, there are categories like DDR1. That is a version, right? DDR1. Then you have DDR2, DDR3, and DDR4. These are some versioning categories. So all are dual data rate RAMs, but you have versions like DDR1, 2, 3, 4. Finish writing? If done, please let me know. Finally, you have the non-volatile memories. The volatile memories are basically depend on the voltage, so depend on the current. So memory reside only when the power is there. When power is not there, memory will automatically erase. So we call volatile memories. Power එක තියෙනකම් memory එක තියෙනවා. If power is not there, the memory will be erased automatically. So that is volatile. Non-volatile memories are basically, so this secondary storage we have already discussed. Secondary storage, optical storage, flash memories or SSDs. So those are non-volatile. And in addition to that, there is another non-volatile memory, which is ROM. ROM or read-only memory. ROM stores, right? ROM or read-only memory stores data written by the manufacturer. Read-only memory. Read-only memory actually stores data written by the manufacturer. Not just data, written stores data and instructions or programs written by the manufacturer. Nishpadagaya hadaneva. So we call them firmware because it is firmware, FIR, firmware. So it is stored by the manufacturer at the manufacturing time. So those are called firmware programs. So here, this firmware, actually there are different kind of ROMs available. So due to this, ROM is read-only. Earlier also ROM was read-only. So why ROM need to be writable? Because, you know, hardware started changing rapidly. Earlier days, hardware was not changing rapidly, but nowadays, hardware are changing rapidly. Quick changes. To adapt, to act accord, or to adapt, or maybe to accept these changes, it need this firmware also need to change. Firmware, basically the software drivers, basic hardware drivers. Driver means it's like car and driver. Driver is a special software which drive the hardware. Car and driver. Car is driven by a driver. Similar to that. So let's say you have a hard disk. It has a driver to drive the hard disk. So a pen drive has a driver to drive the pen drive, or manage, manipulate, manage, data transfer, handle, all these things. To do that, there is a firmware. So we call driver. Anyway, to update these drivers, to adjust according to adapt according to the new changes, it is now not just read-only, it is writable. So you have few categories. The first one is original true ROM, TROM, or true ROM, originally read-only memory. Then you have a programmable memory, PROM, which is programmable ROM. So it can write once. It's like empty CD, empty DVD. You can write once. Then you have erasable programmable read-only memory. erasable programmable ROM can be erased using UV light. You need UV light, ultraviolet light, but still you can erase. Then there is another one, that is Eep Rom. That is electronically erasable programmable read-only memory. Electronically, that means you can connect this to electronic circuit and erase. No need to use UV light. So there is a special UV light eraser. Electronically erasable programmable read-only memory. That is called Eep Rom. And the next one is, so there is another category which is not given in the book, but that is the current standards of ROM, that is called flash ROM. Flash ROM. Flashable read-only memory. Flash ROM can be erased using software. So that is the easiest way of erasing. You can flash. Mobile phones and all. Now it's using flash ROM. Please write down this as well. Right. Now you have clear idea about this memory, secondary storage, and now it's time to move to the next chapter. My plan is to discuss this next day, but let me tell you the summary of the chapter, what we are going to discuss here. Right. We are going to discuss about number systems. So basically we will be learning 4 number systems: decimal, binary, octal, hexadecimal. And then, so you know the computer has only 1 and 0. So I'll not teach this part next day. So understand this carefully. Computer has 2 status. The inputs are basically given by the switches. Switch has 2 status, on and off. Switch has 2 status, on and off. So you can represent off is 0, on is 1. So when you take the primary output, it is bulb. In electronic, the primary output is given by a bulb. So bulb has 2 status, on and off. Off is 0, on is 1. So from switch to bulb, the data transferred using wires, or the signals or electrons transferred using wires. Wire has 2 status, that is transporting power or not transporting, moving electrons or not moving, or you can say have power or not having power. So those are the 2 status. So anything you can represent using 1 and 0. So we instruct all the electronic devices using these 2 status, on off, or working, not working status. That is how we instruct the electronic devices. That is the normal mechanism of instructing electronic device. But the thing is, it's very, very difficult to tell everything using 1 and 0. The reason, so you have to explain a number using 1 and 0. Anyway, let's say you have converted to binary and done that. Then you have to convert letters into ones and zeros. So that is also a challenging task, but you have ASCII, EBCDIC like thing. We will learn Unicode like thing to do that task also. Okay, now that is also done. Task number 1 is also done. Task number 1 is basically how we can convert numbers. So there are methods of doing that. You can convert to immediately binary conversion, or you have some other methods like representing them using ones complement, sign and magnitude. Here we will be learning integers. You can represent using ones complement, sign and magnitude, twos complement. And if it is a non-integer number, floating point number, you have floating point representation, or you have MIPS or IEEE 754 format for representing them in floating point. You have methods that you will learn in this chapter. And not only that, you will be learning character representation, which is done using ASCII, EBCDIC, and BCD, EBCDIC, ASCII, then extended ASCII. And not just that, you will be learning about this after extended ASCII, will be learning Unicode. So those things will be there. Okay, after that, after this and that, then you have picture representation, which you will not learn in A levels, but if you are doing a degree, you will learn how to represent pictures using binaries. Then sound representation. So that is also, you will be not learning in the A levels. You will learn that in advanced level, not in A level, but in advanced level. A level is a basic level, advanced level is your university level. So in that, you will be learning that. So then video representation, anything, a file representation, there are methods, we will be learning that. Not here, again in the degrees. But here you have very few things, representing characters, representing floating and integer, and floating also removed from the syllabus. Earlier days, the floating representation was there, floating point, but now it's removed. Only integer representation, and then the character representation, and the different binary arithmetic operations. So that is a simple chapter. We will start that next day. Okay, I'll stop with this. Today, next day, I'll be discussing the chapter number 3. Good night.
Thank you, sir.
Okay.
Thank you, sir.